Welcome back everybody. Today we're going to be taking a quick look at an eicr we did recently, but more specifically the ring circuit continuity testing. We're going to take a look at line, neutral and CPC end-to-end tests, how we tested for R1, R2, and we will discuss contact resistance through aging electrical accessories. We'll touch on the expected values for each test and why they may differ from the expected results. And finally, we'll look at the R1 plus Rn test that's often overlooked by electricians. Now we're going to do the end-to-end test on the ring circuit. We are going to start with the line conductors first, which gives us a reading of 0.48. Then we're going to move on to the neutral conductors, and what we're looking for is substantially the same reading. So there you go, 0.48 is exactly what we're looking for. With 2.5 and 1.5 millimeter square cable, what we're looking for is 1.67 times greater on the CPC. So the line conductor 0.48 times 1.67 equals 0.80. We got 0.81, so that's near as damn it. Now we're going to test the R1, R2 at each point on the ring circuit. We're going to do this by connecting the outgoing line conductor with the incoming CPC and vice versa. With this particular fuse board, it's going to be quite difficult to identify the outgoing and incoming legs. So what I'm going to do is I'm going to go out onto site and take off a socket and do it there. First of all, we're going to make sure this is actually part of the ring circuit. So we're going to do our end-to-end tests on the lines, 0.49, which is pretty much what we was getting at the board, so that's all good. Then we're going to make our cross connections like we would have done at the fuse board if it wasn't so messy. Obviously you need to make sure the conductors are put away back in the fuse board. So put the line in the MCB, the neutral in the neutral bar, and the CPC in the earth bar. Once our cross connections have been made, we need to test at each point of the ring circuit between line and CPC. We can do this with a 3-pin plug supplied by the MFD, or we can use an adapter as seen on the screen now. The value obtained at each point in the ring circuit should be equal to the R1 loop plus the CPC loop divided by 4, but spurs of the ring circuit are likely to be higher. The outlet we're looking at here has given us a substantially higher reading, so this socket is either a very long spur or there is a high resistance through the accessories contacts. If we drop the socket forward and test at the terminals behind, as long as the point forms part of the ring and not a spur, we should get a reading equal to R1 plus R2 divided by 4. And this reading should be seen at each point wired directly onto the ring circuit. In this case, the line loop 0.48 plus the CPC loop 0.80 divided by 4 equals 0.32. The highest R1, R2 reading should then be recorded on the eicr report as R1, R2. And finally, the R1, Rn test. This test is necessary to prove polarity, because when testing R1, R2, it's possible that the line and CPC at a given point has been reversed, but a reading will still be obtained. It's also useful to determine if any interconnections or spurs exist where there are parallel paths on the CPC. But to my knowledge, this test is rarely carried out, as many argue that the live test will pick up on any line CPC reversal, and therefore they consider it a waste of time. What do you think?